Hi guys, happy Friday. I am going to do just a quick little lesson for you that I was planning on doing at the start of class. I was not planning on being gone today. My poor little boy was up sick all night. So we're going to do long division and completing the square, which sound like a wonderful flashback to algebra, which it is. But then we're going to use that to do some integration techniques. So first thing we're going to look at is some long division stuff, remind you of that. By the way, I feel like it's really important that you guys know that it is 5:37 in the morning and I am in my classroom making this video for you, and I am not the only teacher here. Mr. Dickey is in his office blasting music for some reason. It's something I feel like you needed to know. All right, long division. We're gonna look at a couple of examples here. X cubed minus 4x squared plus 2x plus 5 over x minus 2. So you guys might be given something like this in the form of an integrand, and it seems like, all right, there's this numerator, there's this denominator, U substitution won't work. So what you do is you do long division. So I do want to point out that a lot of you guys probably know that wonderful shortcut of synthetic division, and that can and will work, but only if the denominator is linear. All right, so I'm going to remind you of how that works, but again, it only works if the denominator is linear. I'll give you another example of when it doesn't work. So if it's linear, what you can do is you take this x minus 2, and because it's a minus 2, you put a positive 2 in this little box right here, and then you line up all these coefficients. So the x cubed is a 1x cubed, this is a negative 4x squared, this is a 2x, and then this is a 5. So you just line up all those coefficients, and I'm sure this process will look familiar as I do it. The 1 just kind of moves down to the bottom like this, and then you start this process of multiplying and then adding, and then multiplying and then adding. So we multiply this 1 times this 2 and put your product right here, and then add these two together and put your sum right here, and then you just repeat till you run out of space. Multiply these two together and put your product right here, add these two and put your sum right here, multiply these two together, put your product right here, add these, and we get your sum. So then just to remind you how everything gets set up, this last number right here is always the remainder. So the remainder of 1 gets written over the x minus 2, and it's positive 1. Then this number next to it is always the constant, so there's a negative 2. The number next to that is attached to the x term, so that would be a negative 2x, and the number next to that is attached to the x squared term. If you had more terms, you'd keep going. There'd be an x cubed, x to the 4th. So this is your answer, and then if we're doing calculus, you would integrate this, and you're able to integrate this, and this, and this, and this. We just weren't able to integrate it when it was all together. We're not integrating yet. I just want to show you how the long division works for right now. And then here's another example where you actually have to do it the long division way because the denominator is not linear. So if you're given something that looks like this, you have a 2x squared minus 1 in the denominator, that you would have to set up the long division. So we put our divisor, our 2x squared minus 1, and then we have our whole big division symbol right here. So this is polynomial long division, which works much the same as just numerical long division does. So I'll remind you guys, it's probably been a few years since you've seen it. So you take this term, basically just the one term right here is your focus, and you try to divide it into this term. And by divide, I mean, what does this have to multiply by in order to result in this? So 2x squared times what gives me 4x cubed, and that would be a 2x. 2x squared times 2x would give me this. So I put the 2x in this spot right here, just like you do with numbers. With numbers, it'd be like, how many times does this divide into this? You put the answer up here. And then we take this 2x, multiply it by the divisor right here, and we subtract it from the current polynomial. So 2x times 2x squared is 4x cubed, which it should be because that's why we picked it. And then 2x times a negative 1 would be a negative 2x. Close the parentheses, subtract. So we subtract and those will cancel. And then subtract here and be careful because this is not a like term situation. So I'm just going to take the negative 2x squared, and then it's minus a negative 2x, so plus 2x. And while I'm at it, I'm going to just bring that negative 3 down and then do this process again. So how many times does this go into this? And 2x squared dividing into this. What do I multiply this by to get this? And that would be a -1. Okay, so I put a -1 right here. I take this, multiply it here, and I subtract the results. So -1 times 2x squared, -1 times -1 would be a +1, and I subtract. So these cancel. This just kind of moves right down because there's nothing to subtract. There are no like terms. And then we have -3 minus 1, so that's a -4. This does not divide into this anymore. This is too big, so that's how I know this is my remainder. So my answer here, I take the 2x minus 1 from up at the top, plus, and then this is my remainder over my divisor. And then this is what you'd integrate. All right, so this one would be quite a bit more complicated than this one, but we're not actually integrating these. Remember, I'm just walking you through the steps of long division. Okay, so now what I want you to do is take a look at the Schoology quiz that you have, okay? So if you need to, pause the video, open up the Schoology quiz that we have that's listed for today, and we're gonna do number 1 together. All right, so number 1 on our Schoology quiz looks like this. Okay, so I am going to do this the long division way. This is a linear piece, so technically if you wanted to, you could divide everything by 2 and do the synthetic division, because to do the synthetic division, not only does this have to be linear, this has to just be an x. And plus, like I said, sometimes you can't use the synthetic division, so it's probably it's a good habit to just be able to do the regular long division anyway. So we're looking at this. A u substitution doesn't make any sense because even if I tried to use the denominator, you've got this 12x squared, and how would that get subbed out? It's not one of the inverse trig that we were talking about yesterday. So this one, you try long division. And here's how you know that you try long division. If you have a quotient like this and the numerator has a bigger degree, okay, I'll say that again. If you have a quotient and the numerator has a bigger degree, that's the integration technique that I want you to try. I want you to try to do the long division, set it back up in the integrand, and then take it piece by piece like you would with this one. So 12x squared divided by, and I'm going to add some extra space there, 2x plus 1. So we'll repeat this long division process. We look just at this piece right here. We divide it into this. So 2x divided into this, meaning 2x times what gives me this, and that would be a 6x. So I take this 6x, multiply it by this binomial, and subtract. So 6x times 2x is a 12x squared. 6x times 1 is a 6x. And I subtract. So I have nothing and then minus a 6x. That's a -6x. And nothing to bring down. So I just go into my next round. 2x divided into -6x. So 2x times a -3 would give me this -6x. So I take the -3, distribute it to the 2x plus 1. -3 times 2x, -3 times 1. -6x minus a negative, so plus, which means that cancels. So there's nothing here minus a -3, so that would be a +3. All right, so now that's my remainder. I can set up my integrand. So my integral is now this stuff, so 6x minus 3, and then plus, here's my remainder of 3 over 2x plus 1 dx. Okay, so technically we can set up like all these little antiderivative pieces. So antiderivative of 6x, no problem, that's a 3x squared, minus antiderivative of 3 would be a 3x. That part is no problem. Now we're gonna focus on this. Okay, so I'm gonna do a separate little piece down here. And here's what I'm gonna do. It's definitely not the inverse trig like we tried yesterday because nothing down here is squared, nothing's under a square root. So we are going to do a u substitution. And so the part that looks like it's physically nested is this piece down here. So I'm gonna set up u equals 2x plus 1. And so then you do your du. So du is equal, the derivative of 2x plus 1 is just a 2 dx. I don't have a 2 dx, I do have a 3 dx, but that doesn't do me much good. So I'm just gonna solve for this so I can replace this. So that would be a 1/2 du is equal to dx. All right, so let's set that up. So integral, so this 3 that was in the numerator, I'm just gonna move it out front, replace it with a 1. The 2x plus 1 is a u in my denominator here. And then the dx, according to this, I'm replacing with 1/2 du. So the 1/2 will go out front, the du will go in the end. And then I just take the antiderivative of this. So that is 3/2. And the antiderivative of 1 over u, we saw this a couple times in the last couple days, it's the natural log of the absolute value of u plus c, and then finish it off by replacing the u back. We do that, we replace the u if it's an indefinite integral. And the u is 2x plus 1, and then still plus c. So now that is going to join what we had up here so far. So then plus 3/2 times the natural log of the absolute value of 2x plus 1 plus c. And you guys should be looking at that Schoology quiz in front of you, and you will find that that answer is letter C. Okay, so that's our long division stuff. A little flashback to that. We are now going to do a little flashback to completing the square. That is the final integration technique that we will learn in this chapter. So completing the square, going to do a couple of examples here to remind you. All right, so completing the square, we're going to do a couple of just like algebra examples first, and then bring it into calculus, just like we did with the long division stuff. So we are going to take 5 plus 6x minus x squared, and we're going to complete the square. Okay, so this is kind of backwards in reverse order. So I'm going to put it back into its natural order, like this. So with completing the square, you always take just the ax squared and the bx term, and we do the completing the square. So this is not really solving by completing the square, it's just rearranging this expression into something that's going to look like this. Okay, like this is our goal, is to make this look like this. So this piece right here, notice this is just an x, which means we need to factor out anything that's here. So we're just going to pull a negative, put it out front, factor a negative just from these two pieces right here. Plus 5 was not affected, because this is going to end up transforming to my constant. This is eventually going to be this here. So by completing the square, if you remember how this step works, I take this middle term right here, I cut it in half, and then I take that half and I square it. Okay, so then that gets put into the parentheses. So now this is what we call a perfect square trinomial. I'll be able to factor it down into this form. The 5 was still there, but what I just did is I just threw something into the expression that wasn't there before. So we need to make sure that we're balancing it out. So even though obviously this looks like a 9, it was technically a negative 9. So to balance the negative 9, I'm going to put a plus 9 right here. All right, so this, I have a negative. This now factors to x minus 3 squared, and this adds up to a 14. All right, so that's what completing the square looks like. Now it matches this form. Okay, I feel like that's probably a little bit fresher in our minds, so I'm just going to stick with that one example. I want you to go back to your Schoology quiz, and we are going to look at number 2 on the Schoology quiz. So again, if you need to pause and get that back open, feel free. Okay, so this is number 2 on our Schoology quiz. We are going to end up completing the square if you look at this denominator right here. And things that you might try would include, so like I'm just going to make a little note here, that you might try these things even though they're wrong. You might look at this underneath the square root and be like, oh, this would make a great u equals, a great u substitution. And then you do your du and you get a negative 2x minus 4 dx, and like none of that stuff is anywhere else here. And remember, you can't just manipulate variables, so this is a no-go. That does not work. So when you have a square root in the denominator, it's probably inverse sign, like we learned yesterday. Okay, so I want to put that up on the screen just to get you refamiliarized, and it is still up on the board right now. So if we can make this look like this, then we can turn it into this. And it looks a little bit far off, but it's actually not that terrible. We can do a u substitute, we can do completing the square with this denominator, okay? So we are gonna pull out just this denominator and focus on doing completing the square, all right? So I want to focus on just this part, just like we did up here. So I'm gonna take out a negative, and that leaves me with x squared plus 4x. I take this 4, this middle term. First thing I do is cut it in half. Then I take that half and I square it, that gives me 4. So 4 is what I'm going to put into my numerator right here. I don't know why I said numerator. It's part of the denominator, but it's just an expression. I'm very tired. This 4 right here, it's a 4 inside the parentheses, but remember, just like the problem up above, it's technically a negative 4 that I just put into my expression that wasn't there before. So I'm going to put a positive 4 right here to keep it balanced. So now this is a 16 minus, and this is x plus 2 squared. Okay, so now it's like starting to take shape and look like this. So I'm going to put it back into my integrand. Okay, so now let's pick apart why it doesn't look like this. First thing we looked at when we were doing yesterday's stuff is this 1. That is supposed to be a 1. If it's not, we need to factor something out and make it a 1. So under that radical sign, I'm going to factor out a 16. So this would be x plus 2 squared over 16. Big radical. So now this 16 can factor out. Okay, so this constant, I'm going to pull out front. Okay, so this is an 8. This is the square root of 16, which is 4. So 8 over 4, I can bring a 2 out front, and then this looks much better. I don't know why this table is bouncing so much. All right, so now this is what we did a lot of with yesterday's work. We are almost matching this right here, but this u squared has to replace this right here. All right, so the substitution that we're going to make, I'm going to start to write it up here. U squared has to equal the x plus 2 squared over 16. That means that u has to equal just x plus 2 over 4. All right, so I want you to think of that as like 1/4 x plus 1/2. Okay, don't let this format freak you out. You can just divide them each by 4. So that means that du is equal to a 1/4 x, no, not 1/4 x, just a 1/4. That's the derivative of this, dx. And I don't have a 1/4 here, so I want to replace just the dx right here. So I multiply both sides by 4. So a 4 du will replace my dx. Okay, so this all right here is my u substitution. So now I start with this 2 outside of my integrand. I have 1 over big square root, so I have 1 minus, now this whole thing that I circled right here got replaced with a u squared, which is perfect. Then the dx that I underlined right here is getting replaced with a 4 du. So I'm going to multiply this by 4 out front. I'm going to put the du at the end, and then this perfectly matches what I'm supposed to have right here. So there's an 8 out front, and then this is this, my sine inverse of u plus c. So just sub that u back in. Remember, u is x plus 2 over 4. Don't forget your plus c. And if you look at your Schoology quiz, that would be letter D. All right, so the rest of the time, you guys are working on the rest of that Schoology quiz. Please work together, and then you guys have a very, very, very short video for Monday. Have a wonderful weekend. So sorry about this, guys. I don't love being out, especially when the material's a little tricky. Pray for my poor little baby boy.